Assalamualaikum and hello to everyone. My name is Lumakim bin Asrul Nizam. My registration number is A24KA0080. So I am from Group 9 Expert, and my group is assigned to talk about rock quality designation, which is RQD. So without further ado, let's jump into the topic. Okay, so first of all, let's talk about some brief introduction regarding the RQD topic. Okay, so the first point is the definition. It is a standard parameter in geotechnical engineering used to quantify the quality of rock mass from drill core samples. It is calculated as the percentage of sound rock pieces recovered that are 100 mm or more. Okay. Secondly, let's talk about purpose and the significance. The standardization replaces subjective descriptions with a numerical index 0% to 100%. For site characterization, it is essential for evaluating the stability of tunnels, slopes, and building foundations. The core recovery, it helps engineers distinguish between solid bedrock and highly fractured or weathered zones. Okay, so for the theory part, RQD measures rock quality based on intact core pieces, which are more than 100 mm or 10 cm. So here comes the question: why RQD is important? Because it shows degree of fracturing in rock, it indicates strength and stability, and also is used in rock mass rating, or we can call it as RMR in short, and Q system. Okay, so how it works? Rock cores are obtained from drilling. Only pieces which are more than 100 mm are counted. Smaller fragments are ignored, and the result is given as a percentage. So here's the classification based on the percentage of the RQD. 0 to 25% is very poor. 25 to 50% is classified as poor. 50 to 75 is fair. 75 to 90% good. While for 90 to 100% is excellent. High RQD, it is strong and intact rock, while for low RQD is highly fractured and weak rock. Okay, here comes the calculation part of the RQD. Okay, so first of all, let's talk about the left side of the core sample. For core length, which is more than 100 mm, we indicate it as XI. The blue line is artificial joint, while green and red both are natural joint. If you notice, there are two circles which I've marked as purple and dark green. The purple circles indicate when artificial meets natural. With that, we need to add them all together, exactly like the A plus N bracket over here. While for the dark green circle, it indicates artificial crosses natural. That means we need to pick the XI more than 100 mm within the affected core length only. In this case, 135 mm is affected, so we need to add this length into the RQD calculation. After we get the sum of XI, we divide them by 1500 mm, which is the total core length of the sample, and then times with 100%. So the result shows 83.7%, which means it can be classified as good core sample. Okay, now that we are at the end of our topic, which is about the RQD. Okay, so for the conclusion, the first point is quantitative index. RQD serves as a standard, inexpensive, and quick method to quantify the quality of a rock mass from borehole core samples. Okay, secondly, engineering suitability. A higher RQD percentage correlates directly with increased rock strength and stability for structural foundations. And third point is design integration. RQD values are essential inputs for further rock mass classification systems such as the RMR, which is rock mass rating, and Q system. And last but not least, site-specific decision making. Accurate RQD logging ensures safe engineering designs by identifying zones that require reinforcement, such as rock bolts or grouting, or deeper excavation. Okay, so I have finished with my presentation about the RQD topic. And again, I am Lukman Hakim Besrizam from Group 9 Expert. Would like to thank to you guys for willing to hear to my presentation. And I hope I can give you inputs and um, at least some of the knowledge about the RQD. Okay, Thank you for listening.